Our goal for today is to analyze trig functions. We're going to graph cosecant of x, secant of x, tangent of x, and cotangent of x. So first we're going to look at our sine of x and our cosine of x. So I have them graphed here, and as we can remember, our period of sine is 2 pi, and we're always going to graph two periods of our functions. So we have one period over here and one period over here. That's why it's scaled from negative 2 pi to 2 pi. We know our domain is going to be from negative infinity to infinity. Our range goes from negative 1 to 1, as determined by our amplitude, negative 1 all the way up to 1. Those are included. Our symmetry is odd, and we can tell that by looking at our graph, because we can flip it this way over the y-axis, then flip it over the x-axis, and it'll match up. Our extrema is going to be a little bit different than the way we're used to writing it. So for extrema, we're going to have an absolute max of 1 at pi over 2 plus 2 pi k, where k is an element of the integers. So we can see that our absolute max here is at pi over 2, and if we can add 2 pi, we'll be over here somewhere, but if we can subtract 2 pi, we'll go over 1 pi, 2 pi, we can see we hit that max again, and it's going to happen for every 2 pi k, where k is an element of the integers. We are also going to have an absolute min of negative 1, and negative 1 occurs at 3 pi over 2 plus 2 pi k. And we've already stated that k is an element of the integers, so we can leave it at that. We also want to know for increase and decrease. So our sine function oscillates, so we can just write oscillates, and there are no asymptotes. Now we're going to do something similar for our cosine function. Our period is 2 pi. Our domain again is negative infinity to infinity. Our range, negative 1 to 1. Here our symmetry is even. Again, by looking at the graph, we can reflect it over the y-axis and it'll match up. And then our extrema is going to be different than what it was for our sine function. Our extrema for our cosine function, we're going to have an absolute max of 1 that occurs here. It occurs at 0, and when we add 2 pi, we get back to our max. So 0 plus 2 pi is the same as 2 pi. So we can say 2 pi k, where k is an element of the integers. This little z is our integers. And likewise, we can say we have an absolute min of negative 1. Here, our negative 1 occurs at pi plus 2 pi k. Because if we subtract 2 pi, subtract another pi, we're back at our min. It would be the same if we went the other way. Again, our function is going to oscillate. And then our asymptotes, there are none. Okay? So now let's move on to our other functions. So we know we have cosecant of x. So we know that cosecant is the reciprocal of sine. So we're going to draw our dots for sine just so that we can see them. I'll draw them in blue. So for sine we have 0, here, 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 and then down to negative 1, 0, 1, and then back at 0. Okay, so those are our dots for sine. So now, since cosecant is the reciprocal of sine, we're going to take the reciprocal of each of these points. Now, wherever sine was 0, where it crosses the x-axis, the reciprocal is going to be 1 over 0. So this is undefined, and we'll have an asymptote. An asymptote here at 0. There's going to be an asymptote here at pi, at 2 pi, negative pi, and again at negative 2 pi. So we can draw our sine function just so that we can see it here. So now we would need to take the reciprocal of the next point. So wherever we've reached max, to take the reciprocal, it's going to go the opposite direction. So we'll get these little tiny parabolas that have their mins and maxes at the points of 1 and negative 1. All these little tiny parabolas. And it'll keep going. So now our period is still 2 pi, but our domain is different because we can't include these asymptotes. So our domain is going to be where x does not equal pi k, k an element of the integers. The reason it's pi k is because every time we're at pi, 2 pi, negative pi, we have an asymptote. Our range is going to go from negative infinity up to negative 1, union with 1 to infinity. And this you can see because we go up to this point of negative 1, and there's nothing in between there till we get up to 1. Our symmetry is odd. And now here it's going to be a little bit different. We're going to have a relative max of negative 1 at 3 pi over 2 plus 2 pi k, where k is an element of the integers. Because we can see this is a maximum here, but it's relative because there's still stuff higher. So this max is at 3 pi over 2. If we subtract or add 2 pi, we'll get to another max. And also we'll have a relative min of 1 at pi over 2 plus 2 pi k. And then for increase and decrease, it's going to oscillate. And asymptotes, we have asymptotes, so this one's going to be a little different than our sine. We have asymptotes where our domain does not exist. So we can have all these points. So our asymptotes are going to be where x equals pi times k. Alright? So now we're going to do something similar for secant, because we know secant is the reciprocal of cosine. So we can draw our dots for cosine. Okay, so these are my dots for cosine. We can sketch the graph. So that's going to be our cosine. Now, similarly, wherever cosine crossed the x-axis, when we take the reciprocal of these points, we're going to have an asymptote. So we'll have an asymptote at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on and so forth. So these are our asymptotes. And now we're going to take the reciprocal just like we did for cosecant. And it's little parabolas at all of these max and min points of cosine. Okay? So now our period, again, this is going to be the same as cosine, is 2 pi. Our domain is going to be where these asymptotes are not. So our domain is going to be x is not equal to pi over 2 plus pi k, where k is an element of the integers. Can we see every time we add pi, we reach another asymptote? So from pi over 2, we can subtract. Our range, negative infinity to negative 1, union with 1 to infinity, just like cosecant. Our symmetry is even, because we can reflect it over the y-axis and it'll match up. For an extrema, it's going to be slightly different. We'll have a relative max of negative 1 at x equals pi plus 2 pi k, where k is an element of the integers, because our max is occurring at pi, and then we can subtract pi or then add pi. And we'll have a relative min of 1 at x equals 2 pi k. And we can say this because our min occurs at 0, we can just add 2 pi or subtract 2 pi to get to our next one. For increase and decrease, it oscillates. And then our asymptotes here, we have one at pi over 2, so our asymptotes is basically where our domain does not exist. Is pi over 2 plus pi k, and I forgot that does not equal up here, so the domain does not exist at those points. And then our asymptotes are where our domain does not exist. Alright, so that's cosecant and secant, which is our reciprocals of sine and cosine. Now let's look at tangent and cotangent. So we know that tangent is sine over cosine. So tangent, just a reminder, is sine over cosine. So it might help to have your unit circle handy for this one. So we're going to scale our axes from negative pi to pi, because from the last unit we said that the period of tangent was pi. So we're going to start at 0. So let's look at our unit circle. And at 0, we have the point 1, 0, which is cosine sine. So to do sine over cosine, we'll have 0 over 1, which is 0. Now, when we look at pi over 2, we have 0, 1, which will have 1 over 0, which is undefined. So we have an asymptote. So at pi over 2, we have an asymptote. Similarly, when we have pi, it's negative 1 over 0. So our asymptote is going to be at negative pi over 2. Okay. So now what we have is this, and now we're going to look at this pi over 4. So at pi over 4, we have square root of 2 over 2, comma square root of 2 over 2, so we'll take this one, put it over this one, and then we'll get 1. Now at 3 pi over 4, we have negative square root of 2 over 2, square root of 2 over 2, so that's going to be negative 1. And that pi is going to be 0. And then similarly going the other direction, negative pi over 4 is going to be negative 1. Then negative 3 pi over 4 is going to be 1. And then negative pi is going to be 0. So what we're going to have is something that looks a little bit like this. And this one, we can't really see where it was drawn. I'm just going to go this way. And like this. Okay. So this is the graph of our tangent function, so now we can analyze it. So our period is pi. Our domain is going to be where we don't have asymptotes, so it's x is not equal to pi over 2 plus pi k, where k is an element of the integers. Our range is going to be negative infinity to infinity, so it goes all the way down, all the way up. We have our symmetry is odd, so you reflect twice. Our extrema, there's no extrema, because it increases indefinitely and decreases indefinitely. Now, increase, decrease, it's going to increase over its domain. So, it's increasing and then increasing some more, so it increases over its domain. Our asymptotes are going to be x equals pi over 2 plus pi k. And we already said k is an element of the integers. We can see we have pi over 2, we go back, pi, we have another asymptote. So now, we're going to look at cotangent. So cotangent might be helpful to kind of keep our tangent graph in view. Cotangent, we know, is the reciprocal of tangent. So anywhere that tangent crosses the x-axis, we're going to have an asymptote for cotangent. So we crossed here, so we have an asymptote here. We crossed the x-axis at pi, so we'll have an asymptote at pi. And we crossed at negative pi, so we'll have an asymptote at negative pi. Now, likewise, wherever the tangent function was undefined, where there was an asymptote, this was 1 over 0, we're now going to cross the x-axis and we'll have 0. So we'll have 0 at pi over 2 and 0 at negative pi over 2. Now, wherever we had 1, the reciprocal of 1 is still 1. So we'll have 1 at pi over 4, and we'll have 1 at negative 3 pi over 4. And then the reciprocal of negative 1 is still negative 1, so 3 pi over 4 is going to be negative 1. Negative pi over 4 is going to be negative 1. And we can see what we have is like tangent function just a little bit backwards, going the other direction. Make sure you don't forget those arrows. So the period here for cotangent is going to be the same as tangent. It's going to be pi. Our domain is going to be where our asymptotes do not exist. So x is not equal to pi k, pi, so you're adding, you're subtracting pi, where k is an element of the integers. Our range is negative infinity to infinity. Our symmetry is odd. There are no extrema. Sorry about that. It's decreasing on its domain. We're going down all across its domain. And our asymptotes are going to be at x equals pi k. And every time we hit a value of pi, here, we're going to have an asymptote. So those are our graphs of tangent of x and cotangent of x. Now, so a couple things to remember. You want to remember to always include k as an element of the integers on at least once per analysis. Graph at least 2 periods of your function. Label all tick marks clearly. And state all answers clearly and neatly. You also want to include the arrows on your functions. And that is it.